We have two cars that are leaving a four-way intersection. One's heading north, one is heading east, and both are traveling at 30 feet per second. And we're asked to kind of model the distance between the cars. In particular, we're asked how far apart the cars are after 1 hour and 12 minutes. And second, we're asked when would the cars be exactly 1 mile apart. So as usual, let's start by drawing a picture. I have a dot representing my intersection here. And this picture, although I was drawing it as a picture of the cars, functions quite well as a coordinate system as well. So let's, like we did with this question about Michael and Aaron, let's model the position of, say, car A and car B as a function of time. So let's say that car A is going east and car B is going north. I'll again write something kind of similar to last time. A of t. What I mean by this is I'm going to specify the position of car A after t seconds. So the y-coordinate of car A is always 0. The x-coordinate of car A is 30t. And now I want to be really careful here because I'm expressing a of t in terms of feet. But the question really asks me to do things, at least here, in terms of miles. So I'm going to just kind of keep that in mind. I'm also wanting to be a little bit careful here because t here, what are the units on t? The units on t, as I've written them here, are seconds. In particular, this 30t is functioning well because t is seconds. After 1 second, we're at 30 feet. After 2 seconds, we're at 60 feet. But we're asked to do this computation. I've written it here in terms of minutes. The question actually gave us 1 hour, 12 minutes. So let me continue and write b of t. Well, b's motion is completely analogous to a's, except that the x position is the term that's constant. So here, I have a formula for a's position and b's position as functions of time, where the units involved are feet and seconds. So let's see if we can model the distance between the cars as a function of t. The distance between the cars is the difference in the x-coordinates squared plus the difference in the y-coordinates squared, and then all under a square root. The difference in the x-coordinates is, well, 30t minus 0. The difference in the y-coordinates is 0 minus 30t. I'm going to be squaring this, so I'm not going to pay too much attention to whether I write it as 30t or negative 30t. 30 squared is 900, so this becomes t times the square root of 1800. And now I want to again just emphasize this t is expressed in terms of seconds, and this number at the end of the day is expressed in terms of feet. So 72 minutes. Let me convert 72 minutes to seconds briefly. My method for converting units is to start with what I'm starting with and then multiply by some conversion factor. I'm going to cancel minutes, so I put minutes in the denominator here, and there are 60 seconds in a minute. So I find that 72 minutes is the same as 4,320 seconds. So I can compute now that the distance after 4,320 seconds is this number of feet. The question actually asked us, although I didn't write it here, to express this distance in terms of miles. So to convert this, I could do something just like I did here. I have this, multiplying this out, I find this is 183,282 feet. Multiplying by a conversion factor to put this in terms of miles, I have that 1 mile is equal to 5,280 feet. The feet cancel here, just like the minutes canceled here before, and I'm left with units in miles, and my actual number is 34.71 miles. So this is our solution to the first part of the question. The second part of the question asks us, when would the cars be exactly 1 mile apart? Or in other words, when would the cars be exactly 5,280 feet apart? This is relatively straightforward. I simply need to know what value to plug in for t here to make this compute to be 5,280. So in particular, this is very easy to solve. I simply divide both sides by the square root of 1,800. And I have a solution in seconds after they leave the intersection.